Collecting real-world data from the real world is time-consuming, it's slow, and it's expensive. It's fundamentally unscalable. And this is exactly what we have been building the Treble SDK to address, to overcome this data bottleneck and to be the simulation and data layer for audio AI development and acoustic virtual prototyping across industries. We're going from it being a powerful simulation tool to being a end-to-end audio AI development and virtual prototyping platform, spanning data, physics-based simulation, and machine learning native workflows. We have many leading tech and AI companies, consumer electronics companies, automotive companies, voice companies, startups, researchers using the SDK to improve machine learning models, to accelerate their development cycles, and improve all kinds of products as well.
Behind every great model, there's an even greater data set. For the development of voice focus, the Treble SDK was an important piece of the puzzle. It enabled us to create thousands of artificial scenes where we could virtually place media devices and background speakers relative to the main speaker to simulate real-world conditions. The result is a dataset and a corresponding model which solves the interfering speaker problem and makes voice agents more reliable in production.
This notion of being able to now, for the first time, simulate dynamic scenes where sources can be moving, people can be moving, listeners, and so on. This is something the industry has been eagerly waiting for, and we're really excited to put it out to the world. And it is really a world's first capability to be able to simulate this with precision and at scale. And you get back results which are exactly comparable to what you would get from a real-world measurement scenario. Our AI research team has been investigating the relationship between data quality and downstream machine learning performance, and they show very unequivocally that better data leads to massive downstream performance improvements.
We found in our study that using Treble data, we get up to 30% lower median word error rates than using GPU RIR data through the improved speech enhancement that we have in the spatial net.
Direction of arrival studies showing a 36% accuracy improvement, source distance estimation showing 51% accuracy improvement. So these are not marginal improvements, but substantial improvements, proving the sort of data hypothesis that better data means better performance.
The hybrid method implemented in Treble demonstrates very good agreement with our measurement results, and we are still very happy to use it as a platform for our virtual testing and prototyping.
So now in Treble, we are introducing the ability to simply access directly pre-made, curated, high-quality acoustics data sets made by the Treble team.
In our collaboration with Treble, as I mentioned, we started with this data set. So the data set itself consists of 10 furnished rooms. One part is the room impulse responses, so that you can freely convolve audio with it as you like. And then there's convolved audio, prepared audio coming from delivery speech test samples. And this is a great data set for benchmarking. As we've already seen in the last 10 years, realistic far-field data has been important for products such as smart speakers, and it'll continue to be important, especially for embodied AI and robotics, such as my friend Richie. Isn't that right, Richie?
Absolutely, that's right. Realistic far-field data is key for making smart speakers and robots like me even more effective and natural. It's exciting to see how this can help shape the future.
As long as you have that dry signal and that IR collection, you can combine them in our scene generator using a set of metadata with conversation rules, with device-specific details and listener rules. And in that scene generator, we handle all of the issues of sequencing, of preserving the information about what is being said when, where, and by whom, and where they are saying it with relationship to the device that is listening.
If you have a lot of simulations that are scattered all over different projects and so on, and you want to have a unified and traceable way of working with that data, then collections are for you. It also addresses the issue of data handoff between different teams. With the collections, we provide a unified interface where the two teams can work and extract data from the same data frame, ensuring easy handoff and so forth. One of the things that you would probably like to extract is spatial information such as source location, receiver location, distance between them, and so forth. The collection features make it very easy to append this metadata to the data frame, so the team that uses the data can use this information when they train their downstream tasks.
Welcome to Treble's flagship event of the year. where we are introducing a major evolution of our platform, as well as showcasing some really interesting new research findings and featuring great guest speakers from the industry.